All right, this is the group quiz at home, which is really the practice test for the last unit of the year. So just follow along. I'll give some good hints of what's going to be on the test as we go through this. So first, draw the angle 315 degrees and convert it to the radian measurement. You might already have this memorized, so that'd be fine. But if not, just in case, just know that we start at the positive x axis, that's 0, and then go 90 degrees counterclockwise. So straight line is 180, and then we have 270 down here. So 315 will be between 270 and this is 360 as well. So that puts us right down the middle, right here. Okay. So if you do the checking here, you'll see that this is a 45-degree reference angle. So the angle it makes with the x-axis is called the reference angle, and that's what lets us figure out the answers for all the cosine and sine and things like that. So if we want to convert this to radians, you might already have that memorized, but if not, just know that there's a simple formula. So 315 degrees times pi over 180, right? And then so basically this turns into 315 over 180 times pi, and you just need to reduce this fraction right here. So I can pull up my calculator here and do 315 divided by 180, and I'll get 1.75, and convert that to a fraction. And then you have 7/4. So you might already know that's 7/4 pi, and if that's the case, that's fine. Just to put the answer. There you go. So 7/4 pi is the same as 315 degrees. All right, next we have a radian, and we just have to convert that to degrees just to make sure we know what we're doing. So if I'm going to convert this to degrees, I would do 7 pi over 3 and multiply it by just the reciprocal, 180 over pi. So it's reversed or inverted. And so the pi's cancel out, and I have to simplify what's 7 times 180 divided by 3. So get the calculator here. I'll do 7 times 180. That equals, and then divide by 3. All right, so that's a 420-degree angle. So I'm going to subtract 360 since it's more than 360. So that's really a 60-degree angle. So it's going to look something like this. There. And draw a triangle here. And with that being a 60-degree angle. All right. So let's put that down. Let's go to number 3. So find one angle with a negative measure that is coterminal with negative 60. So negative 60 would be right here. All right, so we're going to go down 60, so that's technically a negative 60. And coterminal means if we go another 360 all the way around, what will we end up at? So basically we're taking negative 60 and then continuing to go in the negative direction all the way around, right, and landing right where we started. So I'm going to subtract 360 from that. So that's going to give us a negative 420 degrees. In this case, it is, I did subtract 360 because it does say we want another angle with a negative measurement. I could have gone the other way and would give me a positive measurement. So it just depends on the question. Number 4, find the period. So that's how long it takes the function to go through one cycle. So you can see whenever it starts repeating, that's when the next cycle starts. So right here is where the next one would begin. So that's one cycle right here. So you can kind of look at the measurements. This is 2 pi, this is pi. So if we go half of from 0 to pi, that would be, well, half a pi. So it takes pi over 2 to get through one cycle of this cosine function. All right, let's find the exact value of this trigonometric function. Let's move this up a little bit. There we go. Tangent of 855. So you want to probably figure out what the angle is from 0 to 360. So I'm going to take 855 and subtract 360 a few times till I get something that's less than 360 but bigger than 0. So I'm at 455 now. All right, so 135. So this is a 135-degree angle. That'll put us right here. That's one more time. There we go. 135-degree angle, which is a 45-degree reference angle, which is important. All right, so you might remember if we're doing special triangles in our unit or unit circle test, that you might already know that these are the coordinates negative root 2 over 2, comma, root 2 over 2. Of course, the x is negative because we're going this direction, which is, the negative side of the x axis here. So tangent is just going to be, right, that is sine divided by cosine. So we have root 2 over 2 divided by negative root 2 over 2. Basically, these cancel out, top and bottom, left with a negative here, so we have a -1. And remember, that's tangent is the slope of the hypotenuse, so you kind of, since this is a 45-degree angle, you can kind of imagine that this right here, if you did a rise over run, would come out to a negative answer, right? Because this is a negative slope. That's another way of looking at it. Let's find over here, number 6, cosine of negative pi over 6. So you'll probably know that as a 30-degree angle. So that's something that looks like this. This is a 30-degree reference angle. So you might already have this memorized, and if you do, you can just use that. Cosine, just remember, is the x-coordinate, right? So this is going to be on the positive side, so at least I know the answer is going to be positive. And then you just have to know, well, is this a root 3 over 2, or is this a 1/2? If you're not quite sure, we can do the special triangles. Say, well, the hypotenuse is 2, just start off with that fact, and then half of that would be the short leg, and that would make the long leg root 3. And if you want to do cosine, cosine is, I think, adjacent over hypotenuse, right? So we have adjacent would be root 3, hypotenuse would be 2, so root 3 over 2. And your answer should be in this format, no decimals or anything else. All right, so let's go down to the back side here and do some graphing. So we have negative sine of theta plus 1. So our midline, you actually start with the last number here. We're going to have the middle of the graph is going to go through positive 1. So half the graph will be above, half the graph will be below. Our amplitude is going to be 2. So we're going to go up 2. So we're going to go get up to positive 3 up here. That's going to be where the top of the graph goes. And then from here, we can go down 2. So the bottom of the graph will go down to -1. So it's good to kind of know those markers that we're going to be doing something like this. Right? And we don't have any compression horizontally, so because this is just a 1 by default, but it is going to be flipped or inverted, right? So instead of starting on an upward trend, we're going to start downward. So for sine, we know that sine of 0 is 0, sine of pi is 0, and then sine of 2 pi is 0. This is 2 pi at the very end. Right, we have to know that key fact, which means when we graph, and we're going to go down first, so we're going to go down here, halfway between 0 and pi, pi over 2 is going to be -1, and halfway between pi and 2 pi is going to be positive. So we're going to go in that direction just like that. There we go. And then once you have the positive side done, you can just mirror that or just continue the function in the other direction. And then everything should be correct. There we go. All right, let's go and graph cosine of 4 theta or 4x. You know, theta and x are interchangeable, just depends how you're looking at the problem. So again, there is no plus or minus here, so our midline is just right on 0. The amplitude right here in front, there's no number here, so it's automatically a 1. So we're only going to go up to positive 1 and negative 1 down there. That's it. Our period here, see, it's going to be a lot smaller because we're going to have 4 theta, which means we have to fit 4 complete cycles of cosine by the time we get to 2 pi. Okay, so by the time we get here, we have to go through the whole cosine wave, which looks like this, 4 times. So it's going to look like this, and then 2, 3, 4. 4 full times. So it really compresses everything together. So if I need to get through 4 of them by the time I get here, I have to have 2 of them finished by pi, which means I have to have the first one finished by the time I get here. So you see I'm just taking half and divvying it up. So I know from here to here I have to have a full cycle done. So I'm going to go, it means if I know cosine, halfway down is going to be here. So I'm really going to be doing this. Halfway here, there's 2. Halfway here, there's 3. Halfway here, there's 4. Just like that. You're going to take off these points. Don't really need them. They're just helping us where everything starts and finishes. And of course, you can continue the same thing on the other side here. Let's go down to number 9. Midline is at 1. Right here. And I have to get through 2 cycles by the time I get to 2 pi. So here's 2 pi right here. So I have to get through the first one right here. And I'm going to be going up, a full up and then down, right? So the sine wave kind of looks like that. So I'm going to start here, end here, means I have to be at 0 here. I'm going to start by going up. Our amplitude is 1, so I'm going to only go up to here and down to here. Our first cycle is just like that. And then just repeat the pattern one more time. There we go. And then you can continue it on the negative side here, same pattern. And our last one for graphing here, we have a midline of -2. So we're going to be starting way down here. Okay, graphing half a cycle. So I know the whole cycle for cosine looks like this, but we're only going to graph the first half. So we're not going to even have the upward part of the graph. We're just going to start high and finish in the bottom part. So our amplitude is 1, which means we are going to start up here, -1, and finish at 2 pi, down 1. Right in the middle is where I cross 0. So it looks something like this. So I have graphed. You can imagine this just kind of stretched out a little bit in both directions and looks like this. And if we continued it on the other side, it would look like the rest of the graph would be there. So you can kind of see we have the whole wave just kind of stretched out. All right, lastly, just coming up with the equation here, just have to recognize that is this a sine or cosine? Sine, for the most part of how we've been covering it, will start at 0. So this is a good hint that this is not cosine. but you do want to use sine. And the midline, if you think about that, is at 0. So the k here is really plus 0, so we don't have to write that. And then just look at the amplitude. So starting at 0, we're getting up to positive 4 and down to negative 4. So I know the amplitude is 4. So we got 4 sine theta. And since we finish one complete cycle, by the time we get to 2 pi, this is really going to be 1 theta, but we don't really need to put the 1 there. So this is just 4 sine of theta would be our answer. All right, go ahead and do this a few times. Make sure you got it down, and good luck on the test.